Hey, it's Omar. This is the first video going over some basics in the Pandas data science library in Python. In this video, I'll be talking a bit about how to cast different data types. A lot of times we get data and it's like all strings and we want to turn it into numbers, or from numbers to strings, or all that kind of stuff. So I have a Jupyter notebook open, which I'm assuming everyone that's watching this video knows about how to get Jupyter and install it. If not, you can let me know. So first we're going to import the necessary libraries. Okay, and that includes pandas, of course, and matplotlib, pyplot. I'm going to create a fake data set here, which will look something like this. Okay, so these are the column names, month and growth, and we have here month starts at 0 index, so January to December, and then growth. So I mean, this is like some fake data about like a business growth or something like that, right? And then this triple quote is a way of formatting a string where it will take into account the multiple lines, so without having to do, you know, a new line symbol. So what I'm going to do, rather than creating a CSV, is I'm going to import something called IO. And what IO is going to do is going to allow us to turn this variable right here into a file-like structure. I'll show you what I mean. So we'll call something here temp CSV equals IO dot string IO temp1. And all this means is that this temp CSV now is going to be treated as if I had imported an actual file called temp.csv or something like that. All right, so we're gonna call our data frame df pd.read CSV, rather than go like a file structure and be like, you know, slash blah 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 dot CSV, right? Which is what you would normally do in a case where you have a separate CSV file. In this case, I'm just turning it into, I'm just trying to make things more simple for right now. Temp CSV. And then this argument right here, the separator argument, tells it what to look for. So by default, it's set to a comma, right? Because comma separated values. But in this case, our comma separated values are actually separated by spaces. So we'll use an expression for spaces, which is little s, and then plus means one or more little spaces. All right, and then after that, we'll just take a look at what our df looks like. Month, it should have month, growth, and then this corresponding columns. Let's see. All right, it does not, and that's because I spelled temp wrong. There we go. All right, so here we have our index, and then we have our months and our growths. So far, so good. Now, first of all, let's look at these types. Okay, D types. All right, and this, when you push Shift Tab, it'll pop up a little pop-up telling you about what this is all about. So this says return the D types in the data frame. So let's see what happens here. Okay, so it shows that month is an int, 64-bit, and then object is usually like a catch-all term for strings. I mean, if something is a string, it will be known as an object. So it's looking at these percentages here as strings. Let's plot it out. Plot, and it's going to want to take our x and our y. So as our x, let's use this series right here, the month series, df.month, and for our y, we'll do df.growth, which is our growth column. All right. Okay, so let's see what we got here. Okay, so our x is our months, and then our growth is like, it doesn't know. It's just, all it knows is that this is some value called 71%, and then this is another value called 100% and 12%, and it's just corresponding every month with the value that it comes across, right? So 0, 34, 1, 50, 0, 34, 1, 50, right? Okay, so here you can get another example. It's like it's not making any sense. If you turn it into a bar graph, it's like whatever, what you know. And so really what we're getting at is that Python is not recognizing this progression of percentages as actual numbers because, well, it's defined as an object or a string. And it's not built in the plotting. It's not built in that you can just plot something as a string and automatically deduce that it means a percentage. So what we have to do is we have to cast it. We have to turn each one of those percentages into a number, preferably a float that's going to say something about the percentage. You know, instead of 64%, it'll be 0.64. So this is pretty much what this video is about. If you do kind of some searching around, you might see that a series has a method called asType, right? So df.growth, that is our series. A series is like a single column from a data frame. So df.dot, and then let's see here let's see what we have available to us. Let's see if there's something that could be useful. asType, okay, asType. So we're going to cast it as a type. So we want to cast every one of those things as a type, and we'll say, well, let's cast it as a float, right? Maybe it'll work. Let's see. Okay, we get a value error. Okay. Now let's scroll down here to the bottom and see what's going on. Could not convert string to float 71%. Huh. So why would it be saying that? Well, it's because it has something to do with this. If this 71 was just like a string called 71 with an apostrophe right here, then it would be able to convert it into 71.0, right? But because of this percentage, it's throwing it off. So our first thing that we have to do is that we have to remove the percentage marker. There's a string method called strip, which will strip away outside values that match something that you're looking for. And for right now, I just want to run our experiments on something called test series. So we're going to say df.growth, and let's look at our test series. Okay, so pretty much what we've done is we've extracted the growth column from our data frame and we put it in this test series. So now we can mess around as much as we want with test series without worrying that it's going to affect our original data frame. We're gonna use this str, and str pretty much is going to allow us. Well, we can actually see what str does, right, by pressing Shift Tab. Okay, and here I just press it 4 times. So a vectorized string functions for series and index. Okay, it's patterned after Python string methods with some inspiration from R stringer package. Okay, so what this is saying is that it's going to allow us, if we have a series of strings, it will allow us to apply a string method. So there's lots of different string methods. You know, they give some examples here. You can split a string, you can replace something in a string, right? So the method that we're going to do is strip. And again, we want to find out what strip does. We press Shift Tab, and strips the white space from each line, or you can put in the specific values that you want to strip. So what we're going to do is we're going to do this. Boom. We want to get rid of any percentage signs. And let's try this out. Control Enter. Oh, look at that. So that's good. We're almost there. But notice, of course, we have to if we just ran this by itself, it's just going to show us the output, but it's not actually going to save it to test series. So now we're good. All right. So now that we don't have this percentage sign, we can cast it as a float. So let's go. Test series equals test series dot as type. And let's show off our test series. Ooh, look at that. So in this case, we don't have to use a string method because asType assumes that it's going to get a string, but it's going to get a nicely formatted string, i.e. no extra weird symbols or anything like that. So the one thing that I would try to do is that I would try to turn this back into a fraction or decimal, right? And again, this is going to be really easy to do. test series equals test series divided by 100. And let's look at our test series. Perfect. What we can try to do now is we can apply all these things we didn't do that much. We removed the percentage sign. We turned the nicely formatted string into a float, and then we divided the float by 100 to get our percentage. So we can do all three of those things in one fell swoop. And this time we're going to apply it to the actual data frame. All right, so let's take a look here. So df.growth equals df.growth dot string dot strip percentage sign dot as type float and divide that by 100. All right, now let's take it and then after we do that, let's take a look at our df. Beautiful. Now let's plot it out and see what it looks like. So we can access a plot function like this by just giving it the column name. So we got month right here, and then we got growth right here. And there, that makes a lot more sense. We could even do kind. We do kind equals scatter. No. Oh, come on, man. Oh, we gotta put the kind after. When we do a scatter, we can also do a bar. There we go. So we have our months. It's from 0 to 11, and we have the growth at every point in time, which is added as a percentage. Now, of course, we can format these things and make them look nice and all that kind of stuff, but that's not the point of this video. There's kind of pesky here, this idea of month as a number from 0 to 11. It can be a lot better, right? So how about we try another type of casting, which is casting from this int to a month name or a month abbreviation. How can we do that? It's going to be a similar process, but we're going to be working with another library, which intuitively is called calendar. And calendar just has a bunch of different useful methods for dealing with dates. Let's again create a test variable so we can experiment with reckless abandon. We'll call it test month. Okay, so here we go, from 0 to 11. This is our months. You can apply functions to each of these. So using the data frame, every data frame has an apply method to it, right? And this lets you, it lets you invoke a function on values of a series. If we can define a nice function that will allow us to take our int and turn it into a month abbreviation, then we're good, right? So that's why we imported calendar, because calendar can allow us to do that very easily. And I'm gonna do this using a lambda function. So x would be every one of these, right? So x is gonna be 0, then x is gonna be 1, then x is gonna be 2, right? And calendar dot month abbreviation, and we're gonna feed it x. Okay, and then we're gonna see what happens. Let's close this. Okay, interesting. So it went from, for some reason this is blank. This is January, February, March, blah, 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 all the way to November, but no December. What we can deduce from this is that the indexing starts at 1 in this case. It does not start at 0. It's a little bit confusing or inconvenient because everything else has 0 indexing. So, but luckily it's a quick solve. And what we do is we do +1. Anytime we get an x from our series, we're just gonna put in x plus 1 into this month abbreviation, and that works, lo and behold. So that's good. And what we're gonna do is we're just gonna do the same thing now, except we're gonna apply it to our real test series, our real series, which is df.month. Apply lambda x calendar.month abbreviation x plus 1. All right, and then we're going to plot and we'll see what's going on right here. Hey, look at that. January, February, March, December. You can even try to do a bar. There we go. See? So, worked out pretty good. That's it for casting. In the next video, which is going to be posted right here, I'm going to show you how you can combine all the steps that we've taken in this video and bundle it all up into these nice functions, which you can put directly into the .read CSV function in Pandas. That'll make it simpler and look nicer and will be pretty useful.